Welcome back to our tutorial. So I hope you enjoyed the preview of the OpenCV Tracker. So for this one, I'm going to elaborate how we can complete this particular project of using the OpenCV Tracker for regular 2D tracking in the image that from your webcam. So I will divide the tutorial into two parts. So part one is the mouse interaction, because using the mouse in TouchDesigner is not as intuitive in other programming platforms such as Pygame in Python or processing. So we need to have some way to create the tracking interaction as well as the visual feedback in order to give you some idea where you are going to select from your image. So that part one of the tutorial will be the mouse interaction demonstration, and then part two will be the core part of the OpenCV tracking. So let's start with the part one. So I already created this project and empty at this moment with only my image from the video from video device in. So if you need to do mouse, actually all the mouse things will be in mouse in here. And before we put the mouse in your project, so I will consider to use component such that I will save the component to the Patreon post that you can download for use for the second part of the tutorial. So that one I can name it as mouse pick. Okay, so let's go inside. So of course the essential part number one will be the mouse in, that give you XY information of your mouse position. So I will choose, remember from here, normalize, such that the Y position is also normalized in the range of -1 to 1. And then I also use the left mouse button. So I give it a name, LMB, left mouse button, to indicate the status. And then, as I mentioned, I want essentially in the end my TXT and TY will be normalized in the range of 0 to 1. So I first need to normalize it. So let me make a selection of only TX and TY, and then use some math to normalize it from the original -1 to 1 to the new range of 0 to 1. And the second thing is I need to drag the mouse with your finger holding the left mouse button. So in that case, I need to detect the two state of the left mouse button, that is the current one, that is at this moment, at this sample, and also the previous one, that's the last sample. So in that case, I need to remember two. So I will use a feedback for this purpose. And before that, I also need to make a selection with only the left mouse button before sending it to feedback. So for the feedback, I will choose the previous channel as previous times. So that is the one I want. So this one will be the current mouse click indicator. That one will be the previous mouse click indicator. And to play safe, I also use a constant with the same name, LMB, left mouse button with the value 0 to indicate when you just open the project without doing anything, this automatically be 0, the previous mouse state. Okay, with this 3 channel 1, 2 and 3, we are now ready to do the programming. So difficult programming part I already completed for you in a separate Python file. So I'll copy and paste to the script chop to save time, and I'll also explain one by one each of the statement. Okay, I just select all and copy. Go back here to have a script chop, and then select everything from here and then paste. And after the paste, I also need to have the 3 input. First one, mouse position. Second one, current click status, and then the previous click status. So that complete the 3 of them. So let me very quickly go through the script. Okay, so we need NumPy for simple array or actually vector manipulation. So we define B box is actually the bounding box, of left, right, bottom and top, the position that you're going to drag with your mouse pointer, and then the pick is whether this bounding box selected initially false, and when you select the box that will be true. And then C position is the click position when you first put a mouse down to indicate that you want to start dragging your mouse for the selection. Okay, everything in the cook function. So I global all the 3 variables. I need to make changes to them. So it will turn out with 5 separate channel, pick the true or false indicator, and then the 4 left, right, bottom and top measurement normalized in the range of 0 to 1 of the bounding box. That's the rectangle you draw. So first of all, from the first input, the current mouse position txty, and then the current mouse click indicator from second input, last mouse click indicator from the third input. So altogether there are 4 situations. Situation number 1 is the most simple one. Both the last click and current click are 0. That means no one clicking the mouse. So you do not need to do anything. And the second situation is last click is 0. That no one click in the last moment, and then there's a click at this moment, so that means you need to start recording your mouse position, and as well as initialize the bounding box with just the left, right, bottom and top position as the click position, and then pick is false. So the next one is actually this one, that is the both the last click and the current click are 1, so that means you are dragging your mouse to join the rectangle on your screen. So in this case, you need to check if this is the X position is less than the X, the left margin. You need to swap it, and then it otherwise you just update the right margin. And also for the Y dimension as well, if the Y position is less than the top, you need to swap it, and then otherwise you update the top one. Yes. This one is the bottom one. That means I probably make a mistake in the description that when your y is less than the click position y, so that means you need to update the y position here, and then in the end we update the click indicator and also the left, right, and bottom and top for your four margin. That is the tracking case. And the last case is when you have the last one is true and the current one clicking or mouse down is false. So in that case, you're releasing your mouse button finally. So we need to check the width of your bounding box and also the height of the bounding box. If both of them are larger than 0, so you indicate it's a proper selection that indicates a true, and then we'll return the bounding box value together with the pick indicator. So that is the indication. So the result will send to an output chart, and then it eventually go to here. You can have a note here to have a look, and if you want to see it on your full screen, you can temporarily use an off viewer and then drag it to your off viewer and then to send it to your output window. I already make a full screen display that you can actually see like this. So when you drag your mouse from here, so you can see the update of the left and right margin, bottom and top margin around here, and also the pick indicator. So that is the display. And then the next step is, at this moment is extremely difficult to understand where you are pointing to with your mouse and also where your bounding box is. So we need visual response. So visual response is done within your mouse pick by using a rectangle in short. So we are going to use a geometry and also camera and light to render it back into 2D, and that rectangle will also send it out from our component such that you can have that rectangle overlay on your background image. So that is another out. Normally I will use a wireframe material as a material for this geometry because we do not want to obscure the center part of your image. We want to see through it when you are drawing the rectangle. I add it to a null material first because we are going to have more than one material. I'll explain later. And that one will give us, I choose topology wireframe in order to remove the center part. So what I am going to do is geometry here. Translate XY, scale XY, we need to change them according to this left, right, bottom and top measurement to make it bigger, smaller, or change according to your mouse selection, and put it back on top of your own image. So that is my intention. in order to create this one, we need to convert that bounding box into the value that can be understood in the geometry. That will be tx dy and scale x and scale y. So before doing this, I also need to make change in the camera to make sure this is just 2D orthographic projection. Center in the origin with edges 1 instead of 2. So the measurement will be minus 0.5 to positive 0.5. So the difficult part is to make this conversion. So the conversion involves only the left, right, bottom and top. So I make the selection here. Right, bottom and top. So the next step is we need to convert from the normalized range of 0 to 1 to minus 0.5 to 0.5, as well as to calculate the txty from here, and also the scale x and scale y, which essentially is the width and the height of your rectangle. So I will create a component to house it because it's a little bit complex. At the same time, I also need to reuse it in the part 2 of the tutorial. So let's create another base component. I name it like convert range with input chop and output chop. So input chop will be this left, right, bottom and top, and then output chop we are going to calculate. So first of all, we need to separate horizontal and vertical. So horizontal one we have right and left. Vertical one we have top and bottom. First one, txty, how we are going to do so. Txty is actually the mean, there's the center between left and right. So in that case, this is the average between them. So it's pretty straightforward. You use some maths and then you combine the channel with average. And then rename it as tx. You can also rename this chop as tx as well. Ty is the same. Average. And then rename to ty. And then ty again. So there's one more step that I haven't completed yet, is the normalization of the range. As I mentioned that the 4 number around here are normalized in the range of 0 to 1. So the one we are going to use is the range between minus 0.5 to positive 0.5. So that is the one we want to use. So we need to normalize it here first before sending out for the further calculation. So this is the missing step. Okay, so the average may have negative number because the left hand side will be negative. bottom side will be negative. So the second calculation we're going to do is the same for both directions. For the x, we need to do a subtract between right and left, so that will be the width, so that is another we name, so we call it width, or just a W. And then for vertical dimension is also the same. Instead of average, we do a subtraction, and then another we name with H. Okay, ideally we can do the merge now. Tx, ty, w, and h, and send out to output. And before that, I have one hesitation. That hesitation is the full screen displays. I can go back to here. It is not a square, so if we have the width and height like 0.5 and minus 0.5 to positive 0.5 here, and the height will have a different range that we might need to cater for the dimension of our screen. So in that case, I need to go back to the converge range to cater for the aspect ratio. So I need to find from another component of chop called panel. And then by default, this panel is your parent, that getting information of your parent. But if you want to get information from your project one here, so you can add parent dot project with capital A, go to project 1, and then now you can make the selection of your screen height and also selection of your screen width. It will give you 160 and 1536 for my own external monitor. Okay, so with this one you can do the calculation, divide, and then you can also have we name as aspect ratio. For the y value that I calculated, so all of them need to multiply this aspect ratio to make it smaller. So for the ty and also the h as well. Okay, so now we have everything ready. Tx, ty, width, and height. So after you convert the range, and that range will be useful for us to put it inside our geometry, that is our bounding box, with Tx go to the translate x, the center of our rectangle, Ty as well, and then width will be the scale x, height will be the scale y. That will be the proper size use a composite to combine two of them and put it under. So now you have a rectangle which you can draw and then overlay it onto your background. So that is the use of this particular component that we're going to fully make use of in the next tutorial to extract a pattern from your screen as a tracking texture that you can use it to match again any location in your moving images, such as the video device input. So to further enhance this one, as I mentioned, I may also want to add another material like a constant, which I use a transparency alpha of 0.5, and remember to turn on branding if you have this transparency. And with the wireframe connection to the node, I add a switch which is more or less similar to the switch in top and chop, that you can switch between these two materials. And the calculation of this one is actually from pick here. When you select from your output from your script chop, you select just the pick. You can give it a nose as well, and that one will indicate whether you would like to use which material. So when you are drawing the rectangle, you use the wireframe that is an outline only, and then when you make the selection, then you use the solid one with transparency, so that the switch index is actually the pick channel. So now we have this interaction. Selection will be this, and then you confirm will be converted into this particular material. So this is more or less what I would like to demonstrate in this tutorial. And one last thing, you can also try to make use of the output from here is you can crop your own video or whatever image from the input by using the four variables here, left, right, bottom and top, in the crop selection like this. You can put left, right, bottom and top. So your image will be something that you get from your mouse pick output by using the same left, right, bottom and top as your crop. And the other thing you can also put it here is put it in a separate storage that you can use it for tracking afterward. So for example, if you have your image right here, and then you make a selection, so you select, your selection will be here in the cropped image. I make the click and then it's unselect this one, so I need to select again. Okay, so that particular one is something you want to use. So what I need to do is to store this one, and there's also another thing I need to take care of is around here. So the mouse in, if you look at the mouse in within the mouse pick, it will record all the mouse position change or mouse click in whichever location of the screen. That is also within your TouchDesigner design mode panel. So if you need to make sure that you only detect the mouse location in your project 1, you can also specify from here you only want to detect your mouse in project 1. So now you can see when I move my mouse, there's no effect in this mouse in. So the only effect is in here when I make selection. So that one will be here. So when I move my mouse or click anywhere, so that remain the same. So the last part is if you want to store it in a separate storage, I will usually use the catch and make it inactive first. Whenever you want to store, you click the pause so that you store your image. And how to automate this one is again from here, because you have your pick, so that pick you can make a separate selection. You select only the pick, and then you can assign it to your pulse here. Before that, if you make it more perfect or more appropriate, you only detect the logic as the rising edge, so that when the pick turn from 0 to 1, you store your image. But when you position at 1, then you do not want to have the pulse again, so that one you can just transfer it to the pulse and export the chop. So you can now see what happened. I select my face and then confirm, and then I can move around. So whenever I move around, the cache position is actually the moment that I make the selection. So alternatively, for example, if you select other location, and then it's run away. So the position also get this one. So that is something that we prepare for the next tutorial. That's part 2 of the tutorial to work with the real OpenCV Tracker. So for today, this one is also a little bit lengthy on the use of the mouse selection, the use of mouse in, and also the custom script I prepared, and also the conversion of the range to take care of the bounding box, the box visualization. So I hope you enjoy and that prepare for the part 2. So I'm going to save this one, the mouse pick one, and also the convert range in Patreon, so that you can download for the part 2 of the exercise. So until then, stay tuned. Bye bye.